Have you ever looked up at the night sky and wondered, what's out there? What secrets do those twinkling lights hold? It's a question that has captivated humanity for millennia. From ancient civilizations to modern-day scientists, the night sky has always been a source of wonder and curiosity. We gaze at the stars, those distant suns, and ponder our place in the vastness of space. Each star a beacon, a mystery waiting to be unraveled. For centuries, we believed the universe was static, unchanging. The stars seemed fixed in their celestial dance, a cosmic ballet that never altered. But what if I told you that our universe is not a still life, but a dynamic, ever-evolving entity, a place where change is the only constant? What if I told you that the universe is expanding, that the very space between galaxies is stretching, pulling them apart? The idea that the universe is expanding is one of the most profound discoveries in modern astronomy. It was Edwin Hubble who first observed this cosmic phenomenon, forever changing our understanding of the universe. It has revolutionized our understanding of the cosmos and our place within it. No longer do we see the universe as a static backdrop, but as a dynamic, living entity. This expansion isn't like the growth of a city pushing outward into empty land. It's not just a simple spreading out. Instead, it's the very fabric of space itself that is stretching, carrying galaxies along for the ride. Imagine a balloon being inflated, with galaxies as dots on its surface, moving further apart as the balloon expands. The first hints of this cosmic expansion came in the 1920s, thanks to the meticulous work of the renowned astronomer Edwin Hubble. His observations would forever change our understanding of the universe. Using the powerful Hooker telescope at the Mount Wilson Observatory, Hubble meticulously observed distant galaxies, peering deeper into the cosmos than ever before. He noticed something peculiar and groundbreaking. The light from these galaxies was stretched. Its wavelength shifted towards the red end of the spectrum, a phenomenon that puzzled many at the time. This phenomenon, now known as redshift, indicated that these galaxies were moving away from us, suggesting a dynamic and ever-changing universe. Hubble made an even more astonishing observation that would cement his place in the annals of astronomical history. He discovered that the farther away a galaxy was, the faster it seemed to be receding from us, a revelation that was both profound and unexpected. This relationship, now famously known as Hubble's law, provided the first concrete evidence that the universe was not static, but expanding at an accelerating rate. It was as if the universe itself was inflating, carrying galaxies along with it like markers on a balloon, expanding in all directions and reshaping our understanding of the cosmos. Hubble's groundbreaking discovery laid the foundation for modern cosmology, inspiring generations of astronomers to explore the vast, ever-expanding universe. Imagine the universe as the surface of a balloon. Now imagine dots scattered across the surface, representing galaxies. As you inflate the balloon, the dots move further apart. It's crucial to remember that the dots themselves aren't moving across the surface. The space between them is expanding. Another helpful analogy is to think of the universe as a loaf of raisin bread dough. As the dough rises, the raisins embedded within it move apart. The raisins aren't moving through the dough, but are carried along by the dough's expansion. In a similar way, galaxies are carried along by the expansion of space itself. But what is the universe expanding into? This question presupposes that there is an outside to the universe, a concept that challenges our very understanding of space and dimension. One intriguing possibility comes from string theory, a branch of theoretical physics that suggests our universe is not just made up of the three spatial dimensions we experience, length, width and height and time, but of additional hidden dimensions. Imagine these extra dimensions as tightly curled up, much smaller than anything we can currently detect. If our universe is expanding within these higher dimensions, it wouldn't be expanding into anything in the traditional sense. It would be more like stretching within a larger, multi-dimensional framework. Section 5, The Infinite Horizon, a universe without end. Another possibility is that the universe is infinite. Imagine standing on a perfectly flat, endless plane. No matter how far you walk, you never reach an edge. Similarly, the universe might not have a boundary, and the expansion is simply a property of its infinite nature. However, the concept of an infinite universe poses its own set of mind-boggling questions. If the universe is infinite and uniformly filled with matter, wouldn't every line of sight eventually end on the surface of a star? This paradox, known as Olbers's paradox, highlights the complex and sometimes counterintuitive nature of cosmology. Section 6. Our limited view, the observable universe. While the true nature and extent of the universe remain a mystery, we are limited by what we can observe. Our tools and instruments, no matter how advanced, can only capture a fraction of the vast cosmos. The observable universe is a sphere centered on us, encompassing all the light that has had time to reach us since the Big Bang. This sphere is roughly 93 billion light-years in diameter, a staggering distance that boggles the mind. Due to the finite speed of light and the ongoing expansion of space, there are regions of the universe beyond this sphere from which light has not yet had time to reach us. These regions remain hidden, beyond our current observational capabilities. It's akin to looking out at the ocean. Just as the vast expanse of the sea stretches out before us, so too does the universe extend far beyond what we can see. You can only see a certain distance to the horizon. The curvature of the Earth limits our view, creating a boundary that we cannot see past. Beyond that, the Earth's curvature obscures your view. Similarly, the observable universe has its own boundary, defined by the speed of light and the age of the universe. Similarly, the observable universe is our horizon in space. It marks the limit of what we can see and study, a boundary that constantly shifts as the universe expands. We can only see as far as light has had time to travel. As we continue to develop new technologies and methods of observation, we may one day push this boundary further, revealing more of the universe's hidden wonders. Section 7. Echoes of the Big Bang. The expansion of the universe points back to a momentous event, the Big Bang. About 13.8 billion years ago, the universe is thought to have emerged from a state of extreme density and temperature. This wasn't an explosion in the conventional sense, but rather an expansion of space itself, carrying all the matter and energy within it. The Big Bang model is supported by a wealth of observational evidence, including the cosmic microwave background radiation, a faint afterglow of the Big Bang that permeates all of space. This radiation is often described as the echo of the Big Bang, and its discovery in the 1960s provided strong support for the Big Bang theory. Section 8. Unraveling the Cosmos. The quest continues. Today, astronomers and cosmologists continue to study the expansion of the universe in remarkable detail, using powerful telescopes and sophisticated computer simulations. They are measuring the rate of expansion with unprecedented precision, hoping to unravel the mysteries of dark energy, a hypothetical form of energy thought to be responsible for the accelerating expansion of the universe. These studies are not merely academic exercises. They have the potential to revolutionize our understanding of fundamental physics, the nature of space and time, and perhaps even the ultimate fate of the universe. Section 9. A universe of endless wonder. The expanding universe is a testament to the awe-inspiring scale and mystery of the cosmos. It challenges our intuition, stretches our imagination, and reminds us that we are part of something far grander than ourselves. As we continue to explore the universe and unlock its secrets, one thing is certain: the cosmos will continue to inspire wonder and ignite our curiosity for generations to come.